Hello, my friends. It's the NOLA Mathman coming again for another math adventure. Unlike Superman, I cannot leap tall buildings in a single bound, and I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
after watching this video, students will be able to solve quadratic equations by using the quadratic formula. The concept we're looking at is a quadratic function. The skill we're looking at is a quadratic formula, applying the quadratic formula to solve quadratic functions. So with no further ado, let's get into our lesson. So in this first group of problems, we're solving each equation by the quadratic formula. It says round to the nearest tenth if necessary. So the first thing you want to do is write the general standard form for quadratic, which is ax squared plus bx plus c. That's the form it has to be in for you to use the quadratic form. So you pull out the a, b, and c values, which are constants. A is 1, b is 0, since there is no bx term, and c is negative 49. So at this point, the first thing you do when you solve by writing the quadratic formula, you have to write out the quadratic formula. That's always the first step. So that is negative 1 times b plus or minus the square root of b squared minus 4ac, that's in the numerator, divided by the quantity of 2a. So what you do is once you pull out a, b, and c, you simply substitute those values in. A little method that I like to use is we use the open parentheses as a skeletal to let us know that we're going to replace those variables with numbers. And so what we do is replace the values with the numbers that correspond. For instance, b is 0, so every existence of b, we substitute 0. For every existence of a, we represent 1. And for c, we represent negative 49. So once we have it, we simply just do arithmetic. Negative 1 times 0 is 0. 0 squared is 0. Negative 4 times 1 times negative 49 is 196. We have to simplify the radical. So we have the square root of 196 over 2. And you just do order of operations. The next step is take the square root of 196, which is 14. So it's 0 plus or minus 14 over 2. So now that gives us two equations. 0 plus 14, which is basically 14 over 2. And then you'll have 0 minus 14 over 2, which is going to be negative 14 over 2. And so our two x values, once you simplify 14 over 2 and negative 14 over 2, will be 7 and negative 7. And so that should pop up here in a second. And so our values will be negative 7. NOLA Mathman puts the negative 1 first. Typically, that's what we like to do. Put the smaller quantity first. So let's go to 4. X squared plus 11x plus 30 equals 0. Again, we want to write our general standard form, ax squared plus bx plus c equals 0. We want to pull out a. A is 1, b is 11, c is 30. Next thing we do, we write the quadratic formula. X is equal to negative 1 times b plus or minus the square root of b squared minus 4ac. That's all divided by 2a. So at this point, we will put the little skeletal parentheses where we will substitute our numerical values for the variables. We write that out. Blank squared minus 4 times blank over 2 times blank. So now we substitute the values in. B is 11, so we put negative 1 times 11. We put 11 squared under the radical minus 4 times 1 times 30 over 2 times 1. So at this point, we will do a simple arithmetic. You follow order of operations until we solve for x. Negative 1 times 11 is negative 11. Negative 11 squared is 121. Negative 4 times 1 times 30 is negative 120. And that's all over 2, which is the result of multiplying 2 times 1. We do the radical next. 121 minus 120 is 1. So we have negative 1 plus or minus the square root of 1 over 2. Square root of 1 is 1, so we have negative 11 plus or minus 1 over 2. That will give us two equations, or two values for x, which are negative 11 plus 1 over 2 and negative 11 minus 1 over 2. Again, we simplify each of those, and so negative 11 plus 1 is negative 10 over 2. Negative 11 minus 1 over 2 is negative 12 over 2. And when you simplify those two answers, you will get negative 5 and negative 6. So that would be our value. And so we circle that. So next we get another group of problems here. We want to expand it there. And we have 5 through 8, so let's see what the NOLA MATHMAN does next. We're going to do number 6. So we have x squared plus 4x equals negative 1. So again, in order to use a quadratic formula, you have to have it in the form of ax squared plus bx plus c. So you have to add 1 to both sides to make the right side of the equal sign equal to 0. So that's what we do. We left with a quantity of x squared plus 4x plus 1 equals 0. We put the general form below it to match it up. We pull out a, b, and c. A is equal to 1, b is 4, and c is equal to 1. So at this point, we can now write the quadratic formula and substitute our values and solve for x. So we write the formula, negative 1 times b plus or minus the square root of b squared minus 4ac over 2a. And again, the more you write it, the more confident and the more secure this formula becomes. So now we're going to create our little skeletal here. We will substitute the values for a, b, and c into our quadratic formula. So where b is, we will substitute 4. Where a is, we will substitute 1. And where c is, we will represent and substitute 1. So we end up getting negative 1 times 4 plus or minus the square root of 4 squared minus 4 times 1 over 2 times 1. We simplify that and we get negative 4 plus or minus 16 minus 4 over 2. So according to order of operation, we have to simplify into the radical. That will give us negative 4 plus or minus the square root of 12 over 2. Now, we can simplify the square root of 12 even though it's not a perfect square. There's a factor that's a perfect square, which is 4 times 3. So we will break it down so we can simplify that radical. Square root of 4 will end up being 2, so it'll be negative 4 plus or minus 2 times the square root of 3 over 2. So now to simplify our answer, we will take each of the terms and write it over the denominator and then simplify those. So we have negative 4 over 2 plus or minus 2 times the square root of 3 over 2. We can factor out 2 in both quantities, and so the first problem, negative 4 over 2, simplifies to negative 2. We factor 2 out of the 2 terms and we get the square root of 3. And so our answer is negative 2 plus or minus the square root of 3. And that's where the concept of factoring, greatest common factor, can help you simplify your radicals, which happens a lot when you're dealing with the quadratic formula. So now we have problems 9 through 12. We're going to do number 12. We have 2x squared plus 7x equals 9. Again, you must have one side equals 0, so we're going to subtract 9 from both sides, the equal sign, and get the right side equal to 0. We end up with 2x squared plus 7x minus 9 equals 0. We write our standard form below it, so we can pull out a, b, and c like we've been doing. A is going to equal 2. Oh, look, NOLA MATHMAN didn't do it that time. I guess he went straight into the quadratic formula, but I'm sure we would know that you're going to pull out A. A is going to be 2, B is going to be 7, and C is going to be negative 9. So you want to write that out. NOLA MATHMAN is getting a little cocky here. He's so good at it, he doesn't feel like he needs to write it out, but you want to write that out. So where B is, we will substitute 7. Where A is, we will substitute. See, there you go. So you write it down now. So A is 2, B is 7, and C is -9. So the NOLA Mathman came to his senses there and wrote it out there so that it'd be easy for the viewer to understand what he is trying to do there. So we substitute those values in, simplify, using the order of operation rules. We have -7 plus or minus 7 squared, which is 49, plus, because when you multiply -4, -9, and 2, you're left with positive 72, and that is all over 4. So now we simplify the radical. Square root of 49 plus 72, that's square root of 121 over 4. We can now simplify the square root of 121, which is 11. So we have -7 plus or minus 11 over 4. We create two equations, -7 plus 11 over 4, -7 minus 11 over 4. The first equation will get us 4 over 4, which is going to be 1. The second equation will give us -18 over 4, which will simplify to -9 over 2, I believe. So we're going to see that in a sec here. And so you want to do one step at a time like the NOLA Mathman does. And so your answers are going to be 1 and -9 over 2. And so you solved it. Very good job. So we get in the habit of using the quadratic formula to solve quadratic functions. So we got another 2 problems here. And let's see what we're going to do next. Let's see which one we're going to try. We're going to do 13. So we have 3x squared plus 2x plus 3 minus 3, equals 0. It's already in ax plus bx plus c form. So we write that, we pull out a, b, and c. A is 3, b is 2, c is -3. We write down our quadratic formula. We want to do the same steps over and over like the NOLA Mathman is doing. It makes it very easy for you to master and retain the concept. So you write the formula. Where b is, you will substitute 2. Where a is, you will substitute 3. And where c is, you will substitute -3. And then you will find and use the order of operation rules to solve for x like we've been doing. So we plug that in, we get -1 times 2 plus or minus 2 squared minus 4 times 3 times -3 over 2 times 3. -1 times 2 is -2. 2 squared is 4, so in the radical you'll have 4 plus is -4 times -3 times 3 is positive 36, and 2 times 3 is 6, so you have that in the denominator. You'll simplify 4 plus 36, that will give us a square root of 40. We know that that is not a perfect square, but it is a perfect square that's a factor of 40, which is 4. And so we're going to write that as a factor of 4 times 10, so we can simplify the radical. Square root of 4 is going to be 2, so it'll be -2 plus or minus 2 times the square root of 10 over 6. So now we take each of the terms in the numerator and divide them by 6 and simplify as much as possible to get our final answer. -2 over 6 will be, divide both by 2, you get -1/3, and then you divide 2 of the both terms in the second term, and you'll get the square root of 10 over 3. And so our final answer will be, and you can, since they both have the same denominator, you can make it one fraction by putting -1 plus or minus 10 over. It should be -1. It said 1 there, but the NOLA Mathman forgot to put -1. Now we're going to state the discriminant, the value of the discriminant for each equation. By getting the value of discriminant, you can determine the number of solutions it has. So discriminant is the part of the expression under the radical in the quadratic formula, which is b squared minus 4ac. So we pull out a, b, and c because we need those values to get the discriminant. We substitute 4 for b, We substitute 1 for A, and we substitute 3 for C. And so we'll have 4 squared minus 4 times 1 times 3. That will get 16 minus 12, which is equal to 4. So since the discriminant is a positive 4, we know that it will provide 2 real solutions, because whenever the discriminant is a positive number, you will have 2 real solutions. So in this case, we have 2 real solutions. See, the rules follow. If you have a discriminant that's positive, it's 2 solutions. If you have a discriminant that's 0, it's 1 solution. And you have a discriminant that's negative, you'll have no real solution. So that's how the process works. So we'll do another problem here. X squared minus 10x plus 25 equals 0. It's in the form ax squared plus bx plus c equals 0. So we pull out a, b, and c. We write the discriminant, which is b squared minus 4ac. We substitute for b, a, and c, and we will get negative 10 squared. We write out little skeletal things for the places where we will substitute for the variables. And we will substitute negative 10 for b, 1 for a, 25 for c, and we'll get 100 minus 100, and that is equal to 0. And since it's equal to 0, we know that we will have 1 real solution since the discriminant is 0. So that's something you want to learn and have down, that again, when the answer is positive, the discriminant is 2 real solutions. When it's 0, it's 1, and when it's negative, it's no real solution. So I would assume if we do a number 23, we've already done the first 2. So I can assume that this discriminant probably will be a negative number, but we'll see. So we pull out A, B, and C in this problem. A is 2, B is negative 4, C is 10. We write the discriminant down, which is equal to b squared minus 4ac. And we will substitute into our values. So we write our little skeletal to represent the places where we're substituting to our variables. And now we plug in the numbers. Negative 4 for b, 2 for a, 10 for c. And so when we simplify negative 4 squared, that's 16. Negative 4 times 2 times 10 is negative 80. 16 minus 80 is negative 64. And since this discriminant is negative, we know that it will be no real solution. And actually, you'll later learn that it will give you what we call 2 imaginary roots. And so our answer for this is no real solution, meaning no real numbers. And so we have learned how to use the quadratic formula to solve quadratic equations and functions. We learned the importance of the discriminant and how it determines the number of real solutions in a quadratic function. And so until we meet again for another fun math adventure, it is the NOLA Mathman signing off. Have a blessed and prosperous day.